Recently, there has been a growing concern to better understand energetics of vegetable oil as a renewable and less pollutant source of biofuel. Additionally, there has been an interest in foods not only in American culture, but in the modern science classroom as well. Food use and experimentation is advantageous primarily to engage students, especially those at the secondary level, and also poses less safety risks to students. In this laboratory experiment, we chose the following items. Market Pantry vegetable oil. This item was chosen after the recommendation of our teaching assistant Jeff for its oil-based versus water-based properties. Minute Maid cranberry grape juice was used for its similarities to water, but also was interesting to use for our experiment because of the high sugar content and what changes in the data this characteristic would add. Additional materials included tea candles, matches, a thermometer, ring stand, ring clamp, 100 milliliter graduated cylinder, and a balance that weighed out to the hundredth of a gram. Procedure. Place a 100 milliliter sample of varying liquids, oil, juice, or water in the bottom half of a soda can. The temperature should be monitored closely using the thermometer. To warm the substance, the candle will be placed within the petri dish below the soda can at the closest possible proximity to the can containing the varying liquid. The wick was never fully consumed. Lastly, to gauge the change in mass, the candle should be measured initially before being and then again after each interval at 15 degrees in temperature changes. Total measurements for each liquid should be 4 mass measurements. The following pictures are pictures of the experiment setup.
The results of the experiment included one human error when the wax from the candle was spilt onto the floor after the 4th trial for the vegetable oil. Some other results from this experiment, we realized that there was insufficient time to study the energetics of the water for our standard, and then to compare the data, we compared the change in temperature to the change in mass, and then by squaring the temperature, which is the y value, the data linearized better than just having it as a linear slope. This graph includes the initial data, including the error point, and in the next graph shows it removed. As you can see that the r-square value increased and was more closer to 1 once we removed the error point and made the line a lot more linear.
So despite the linear graphs or linear trend lines we were eventually able to get, our data was still insufficient and our r-squared values, none of the data was good enough as we would like it to be. Based on what we saw empirically, we would expect that the vegetable oil would have had the lowest trend line, when in fact it was the opposite that we observed. And then followed by the cranberry juice and then the water. Overall, we're going to analyze the data based on our empirical results rather than what we saw graphically. So we can compare the changes in types of energy that were observed. First of all of our samples started off 100% potential energy defined as chemical energy with little thermal energy being used and no kinetic energy. Looking at the water, it took a lot of wick to burn, so it used up a lot of potential energy with some kinetic energy defined as the gas molecules rising, the RMS of the molecules moving around. There's some contribution kinetic energy as long as we our samples. In the second trial of water, because we used up so much of the wick, we said that the potential energy was almost completely removed, with a lot of thermal energy being used in terms of heating the water. More interestingly, with our actual samples, the cranberry juice seemed to take a lot longer to heat up than the vegetable oil, but less than the water. So looking at it going after the second trial, using the same candles, more and more of the wick was consumed for the cranberry juice with some contribution to kinetic energy, as long as we were heating things up. and then the thermal energy in terms of the heat that was used to increase the cranberry juice's temperature. In contrast, the vegetable oil heated rapidly, the temperature increased rapidly, with little of the wick ever being consumed, even by the end of the day. So we chose samples that contrasted each other, which is interesting. Despite that was kind of a lucky guess. Future studies should include viscosity, studies of viscosity, which is an important property for biofuel efficiency. We would need to do a lot more trials for both of our samples and our standard. In a classroom setting, we would have our students bring in test samples from home, such as shampoo, so that we could study on a broader scale. Lastly, we would like to acknowledge our Professor Sean and the teacher assistants Jeff and Matt and all of our classmates for their input, the University of Iowa for its facilities, and Jeff's High School for additional equipment. Thank you very much.